Okay, welcome everyone. This is the second part of our tools and strategy labs today. We have with us Bhagwan Bolina. He's a passionate cloud security researcher who loves both building and breaking things. And we also have Deepak, who is a security engineer with strong background in web security and growing interest in AI and cybersecurity. So with that, I'll welcome them and let them do the magic on how to pawn the AWS.
Thank you. Thank you. Amit.
Welcome.
So,
Can we get a warm welcome, please?
Hi. So just real quick, show of hands who has any experience with AWS, who has any experience with pen testing AWS. So a lot less. Okay, a lot fewer people. That's good because this is kind of like an introduction to AWS pen testing. So we're going to show you a bunch of misconfigurations and how you can exploit them. Hopefully you get learn something new. And towards the end of the demo, we're going to show a tool called Cloud Nuke, which can be used to delete everything in your AWS account, which is especially useful if you spin up some machines and you kind of forget about it. It'll cost a lot of money. So yeah, hope you all enjoy that. And Bhagwan's going to get started.
Yeah. So hi everyone. Good morning. I hope you all had breakfast. I need some energy. I'll make sure I'll try to keep up the whole session as interactive as possible. And feel free to ask questions, right? And since the whole goal is the learning, and since this is a beginner or introduction kind of thing for the AWS pen testing, if you know anything, it's well and good. If you don't, feel free to write questions if you want to ask in the end, right? So just real quick, like how many of you guys have laptops with you? Like you can do something hands-on. Just raise your hands. You all had breakfast, right? Raise your hands. Okay, super. So
It's all right if you don't have a laptop.
Yeah.
We documented everything and we'll give you a link which you can use to follow and do
So
stuff back home. But
in
yeah.
case if you don't have laptops, if you don't have infra setup with you, it's totally fine because we have documented everything. Yeah. You can access this URL in your laptops or mobile phones any way you can and see. Yeah, I'll just zoom in. Is it okay? Yep. So these are the things we're going to focus today. Like IAM, EC2 misconfigurations, the apps that get hosted in the compute servers. What if they had any vulnerability, and what if they get exploited, and how your cloud accounts gonna get compromised or get affected. So let's start. So people who have not just laptops and their cloud accounts with them as well, you can start creating one of the IAM user. The first thing is you have to access this documentation, which will have creation of IAM users and a couple of scripts that we open sourced. That you're going to download the scripts and execute them to deploy the vulnerable lab. So I'm going to give just 5 minutes. People are trying to do hands-on to create the IAM user first in your cloud account, and then we're going to begin with the lab.
If you have any questions, you don't know how to set that up, please feel free to ask.
Yeah, please feel free to ask questions if you have set up problems with.
If you just want to follow ahead, we can skip ahead.
Or shall I show them how to create as well?
Yeah.
No, sorry. Okay. What do you want? You want to show something like creation of user? You can share that. Let's go to the cloud account. Decent. This one.
Yes. So yeah, if we're just going to create an IAM admin user just real quick if you want to follow along.
So people who want some guidance, like all you have to go is to your IAM users. And people who don't have cloud accounts or laptop, just stay within the documentation. You'll have all the screenshots of creation of accounts, what's getting deployed. So we just want to make sure that you guys need to understand what we are deploying so that you'll be able to understand what we are trying to exploit, which misconfiguration that we're going to exploit it. Just give some random name. So this is a classic example of giving the administrator access to the credentials. This is
Ideally, you shouldn't be
doing this.
We're going to be using this account to provision other resources. So yeah.
So once your account is created with the administrator access, all you have to do is create access keys for them. Yep. So it'll create access key ID and secret key ID for you. So now you have to copy these keys and configure them in your terminal. And for that, here's the documentation how you're gonna copy those keys and save this in your AWS credentials terminal. And then I hope people are doing it. They are done with the creation of the user.
Just quick, show fans who's trying to set up the lab right now.
So that we can focus directly on the concept.
Perfect.
Okay, only one.
Just a few of you. Okay. So I'll help you out directly, and then we can skip our
You should be able to do this with a free tier, right?
Yeah.
Yes.
I mean, don't worry in case we'll make sure that all the resources get deleted, whatever we deploy, right?
Yeah.
In the end, we're gonna delete all of them.
So that's why we have Cloud Nuke at the end. So to make sure you delete everything.
Yeah. So you can feel free to deploy stuff.
Just so you're aware, I tested it out and I kind of forgot to delete it for a couple of days. And it cost like $1. So it's not the most expensive thing in the world, but we still don't want to do that if we can avoid it. Yeah.
$1 lab. So folks, so since only two or three people of you are deploying stuff, so this is the setting up the attacker machine. So this would be your jumper machine, right? Technically, to tell you, the attacker machine is something a jumper machine. From this machine, we want to deploy the instances in your cloud account, and this would be your jumper machine to attack or exploit stuff in your own cloud account, right? So real quick, here's the documentation for installing Terraform, and then create an SSH key, like it's a PEM key to access your own AWS EC2 machine. And this is the repo, which has the Terraform scripts that you can download and deploy your stuff. Once you're done downloading or cloning the GitHub repository, all you have to do is Terraform init. You have to initiate the Terraform and then apply with this AMI ID that's present in the documentation. Yes. And you can access this documentation after this workshop as well. So some of you might want to do after going home. Yeah. So once you're done with deploying Terraform scripts, you have to do an SSH into that jumper machine, whatever we created. And once that's done, don't destroy it. That's the last step. So if you are facing any errors while deploying stuff, we are here to help you out. Just let us know. And this is the most common error, time zone based error. So we have documented that as well in case any one of you are facing an issue, right? So let's quickly get into our topic. So how many of you know AWS IAM? Just please raise your hands as much as you can. AWS IAM. Am I audible till the end? Everyone in the end? Okay, as like, how many people hate IAM? All hate IAM? Makes sense. So, folks, like AWS IAM is your identity access management stuff from the AWS. It basically has four important things, right? Users, groups, roles, and policies. Each one of them plays an important role. And, if it's a startup, like in a startup, then you might have encountered at least once in your lifetime. So, provided your company is using AWS. Not a fan of AWS though. So, yeah. Your users are basically responsible for performing specific tasks in case you assign them a specific policy, to do a specific task. And roles are something that will provide you temporary access credentials, whereas your users, I mean, depending upon how you configure your user credentials to be expired, so they get expired, within the time period that you provide. But roles are something they are provided with temporary access with a session token. So it's not that permanently they'll stay even if they get leaked in the GitHub, right? A lot of times developers or the op folks they just commit the access code which might contain this access key ID and secret key ID. And the moment they get leaked, high chances that your cloud account might get compromised. So, and the third thing is policy. This is something really interesting because we're going to work on it. So, policy is a very short JSON document, right? So, which will have what access. It's basically, right? You all have your badges, right? You all have your badges. So, in case if you have identity card, this is a very bad example. In case if you have an ID card before coming here, your ID card is something which will have your name, right? Might be your role or where you're coming from, something like that, to get access to a building or else getting into it. Yeah. So this is what we call JSON policy document. As I said, like your ID card will have a lot of things which will define you, right? What does it define you? Like who you are, what access do you have in this building, what you can do technically, right? So basically, the statement is something that will have three or four stuff like the action, what action that the user can perform. Again, provided whenever you attach these policy documents to a specific user, that user can perform these tasks, right? Your action is something, as it says, STS assume role, or else the first one is like star. Like, can anyone tell me like what star is in the first JSON document? What does it represent? The wildcard. What's that? Wildcard, right? Everything. Just checking, like, yeah. So, what do you think? I mean, which is more dangerous, the first one or the second one? Why? All rules, right? I mean, technically,
It takes assume role.
exactly. Like technically, you're giving access to anything. That's what my ops people used to do. Whenever they don't want to spend some time and understand what access they want to give to someone, all they do is give admin access to everyone, and then like this is how the policy would look like. Now we're going to see what happens when someone gives like this, and how do you exploit in the real world, right? So this is an example of dangerous policy. So this is the first lab, right? The first lab is basically we're going to do some privilege escalation via policy rollback. So to get started with that, AWS in general provides you 5 policies that you can attach to a specific user. Right? So please do remember this. AWS gives you access that you can assign 5 policies to one user. Why is that? Because let's say if Deepak is a developer in an organization, Deepak has to do multiple things. Like he has to do some give access to dev folks and manage some QA stuff, right? So depending upon that, you can give access to 5 policies, and whenever Deepak wants to shift to a specific policy, he can shift to that policy and he can use that policy, right? So the thing is not, the problem is not giving access to 5 policies. The problem is one of these policies, what if one of these policies might have more privileges, that means that the dangerous privileges, or what if one of these policies can be used to do a privilege escalation? That's the, that's the goal of this lab. So yeah, there are few assumptions to be made before before performing this lab. The assumptions are, I guess all of you have used GitHub, at least once to download something or search something, right? How many of you? Yeah. So let's take a quick scenario. Imagine you're finding something and you're searching something in the GitHub, and accidentally you found AWS credentials, right? AWS credentials of some user or some organization that being leaked in one of the GitHub repository. So what would be? Imagine if you are all attackers here. What is your first task that you would do? I'm just making it interactive so that I want to understand like what exactly so that we can proceed from there. So what do you guys do when you find an innovation? Yes. Yeah. So we're gonna do a quick enumeration step, basically, to understand what access that the keys have, and from there we're gonna proceed further, right? And any answers? Any more answers? Yeah, that's the thing. So, see, so we're gonna do some basic enumeration to understand like what resources access we have. So from there, how we're gonna proceed further to exploit the resources, what based on the access that we have. So here, so I want all of you to imagine that we got access to one of these credentials, right? Now we're gonna do a little bit of enumeration stuff and understand what the specific user has a policy. Let's see what access he has, and from there we're gonna proceed further to do a privilege escalation. So we have deployed this one of the, once you access that EC2 machine or the jumbo machine that we provided, you'll be able to run this command cloud create IAM previous by rollback. This is the scenario that developed by the, again, huge shout out to Rhino Security Labs. So Rhino Security Labs is something that they designed these labs intentionally or deliberately vulnerable to understand the cloud misconfigurations, right? So running this command will deploy a vulnerable infrastructure. So this is how the output would look like. As I said, we're gonna assume something that we found these credentials somewhere in the GitHub to make it more look like real world activity. So the initial setup, you're gonna configure your AWS credentials and then save it in one of the profile, Cloud Goat, to make it easier not to call every time with the name. And once you're done with this, we're gonna do STS get caller identity. That's basically if you wanna verify what user you configured and which will have an AN. Your AN is basically a unique number, which is unique for each and every cloud account or every user in or every resource or entity in the cloud account. Any questions still here? Yeah. Cool. So once you're done with that, we're gonna export the IAM. This is the username. Okay, I'll break down it for you. So AN, this is an AWS cloud provider, and the service that we're gonna use is IAM. Going down forward, you will see AWS :EC2, depending upon the service we're gonna use. Since we just did an AWS STS get caller identity as an API call that belongs to an IAM, it shows an IAM, and this is account ID, right? And this is the user, and he's the user that we got access to from the GitHub credentials, right? So I exported IAM username so that I don't have to type this long username again and again. So you might think, why are we directly going forward for the policy enumeration? Right? There are so many steps as like you can enumerate anything that you want. Let's say if you ever used Windows, right? Net local group, net administrators, WinPress, like you want to see what privilege it has. Similarly, not just the policy. Since this lab is for the role privilege, by rollback. So we are directly heading towards the policy enumeration. But in a real world, you're going to do some different bunch of stuff like enumerating attached policies or list policies, or what access or the roles that that he can assume, the Rainer can assume, right? So we quickly listed the user policy that this username has, and these are the attached policies. Yeah. And then can anyone tell me what's list user policies? Difference between list user policies and attached user policies? Anyone? So list user policies and attached user policies. There will be two different API calls for that. If you look at the command, right? So this is the list user policies, and this attached user policies. Yes. So attachments are coming with the role that you specifically go and attach to that user, right? Now, I'm going to export that as well, because to make our command line easy, folks, if you want to practice again, I mean, I can see some of you are like, want to do hands-on. So if you want to go home and then practice, the whole documentation is available. But all I want to do is like, if you can focus on what exactly we're trying to exploit. Yeah. And then once, as I said, right, each user might have 5 different policies that get attached. So from the above output, what I saw is this is the policy on. As I said, each and every entity and the resource will have unique on, right? So here's the now I'm gonna do enumeration of policies, because I got to know there is one attached policies. Now I want to see how many policies that got attached to this one, like how many versions of the policies. So I'm going to do AWS list, IAM list policy versions minus minus policy and the exported variable from the above command output. And interestingly, there are 5 policy versions, right? As you can see, V1, V2, V3, and V4, V5. And now our goal is we're going to enumerate, or we're going to see what's there in each and every policy document, so that we can decide what to do. What are our further steps as an attacker, right? Now, the command for the API call for that is like get policy version, and you're going to mention which policy version you want to see. Okay. The version ID, the V1, because this is the version ID that's going to give for each policy, and I mentioned it as V1. So this is a V1 policy version, right? So, okay. Quickly open your new tabs in your browsers. It could be phone or your laptops. This is a really quick activity. I just want you to guys tell me, what does that set default policy version does? Yeah, what does that set default policy version does? What does it do? Yes. I mean, by the name itself, it says like, if you want to see anyone, AWS documentation is a great resource. If you are looking and reading it, like what to do and how to do it. It gives very clear documentation that whenever you have that set default policy version, that's basically, if you have that in your policy, it will tell you that you can select which policy to be selected as a default. Right? We have 5 policy documents, but either one of them should be a default policy, right? So this permission is gonna let you which should be a default. But in our case, V1 is the default policy because it's in the policy, it says, right? So V1 version. So now, and the second one, I mean, we don't have to shift though. Can you see that affect resource and then SID? SID is basically ID. You can write anything in that description, kind of description. But what really important is effect and resource. Right? Resource is a wildcard. Technically, you can access any resources that present in the cloud environment. And the effect is something, it's kind of Boolean based, like, either allow or deny, implicit deny or allow. So since it's allow and that resource is wildcard, you'll be able to access anything. So since I have wildcard stuff, but this is fine. But let us look at what all access that I have, right? So when I try to enumerate more policy versions, what I understood is there is one policy version. Initially, we spoke about this one, right? One of the dangerous policy, that action and then the resource is wildcard, so that you are allowed to perform any action on any resources. That means you are technically an administrator. So similarly, we can see in the V3 of the policy version, which says this is the sorry, yeah. So, but yeah, why are we looking for the other one is like for the V1, you'll have a specific conditions like only get and list. You might not have the read or write operations, right? So that's the reason I try to enumerate the other policy versions called V3, and this is how your V3 looks like. It's one of the most dangerous policy. So what I quickly did is I tried to set V3 as our default policy version so that now I'll be able to have similarly like administrator access and they can perform any action on any resource. Yeah.
Do you know, is this scoped to a certain VPC or does it even matter? I don't know if I'm asking.
No. Please.
It looks like is the wild card.
Yes.
Is that just like, does it not matter at that point?
Good question, though. Yeah. Yeah. Thanks. Basically, your IAM is a global entity. It doesn't. It's not like segmented due to a region or something like that. So it's a global entity. Once you have access on the resources and stuff, you'll be able to access in any VPC. Yeah. Yeah. So the moment I shifted my policy version from V1 to V3, I'll be able to do any operation as in just like an administrator, right? So just to quickly verify if I get an administrator like access or not, what I try to do is I've created an user called Bob, right? Just wanted to make sure if I can create an user. So if you see across any incidents that happen in cloud privilege investigations or any incidents that usually happen in breaches, right? Very few attackers would use the accounts that they compromise. A lot of attackers try to create backup users to have a persistent access, right? So, I mean, it's a quick example though, but I just wanted to verify if I got the administrator access. What I did is I tried to create a user. I was able to create an user. That gives a sense of like you are an administrator in the account. And to just, a very real quick recap, this is the exploitation part, which gives you a quick, real, maybe a good understanding of from where we started and where we ended. Initially, we tried to access that Rainer user from one of the GitHub credentials that got leaked. And then we reviewed the IAM policies that got attached to Rainer. And then we set one of the default policy version to V3, which has more access by reading like each and every policy. And then we achieved a full admin powers as Rainer. Yeah. Any questions from this lab? Good. Yeah. Yeah.
Building on your question, like sanity check, you can have so there's different scopes of IAM. You can have the management account with other accounts underneath it. And then you can
Yes.
have
Yeah.
accounts. So there are different scopes to IAM because
You asking some question?
Is this considered like a white box? So I see we got the access credentials for this user, but then to be able to, we're already in, right? Do those credentials give us the all the access we need, or are we? I'm not fully external, right?
Gotcha. So it would, if you were to compare it to like a regular pen test, it would be like they give you credentials for a website, but tell you nothing about the website.
Okay, so kind of like a
Gray box, yeah. So you don't know anything about. In this one, since it's a scenario that's meant to be vulnerable, we know a little bit about the background. I mean, if it's called at privilege escalation via rollback, you kind of know you have to roll back something. That's a hint, right? But apart from that, it's kind of black box. You have credentials, and you're supposed to do all of that enumeration yourself and figure things out. So great.
So yeah, I mean, if I'm not wrong, if your question is like, let's say you got an AWS pen test role or job, right? You're doing it, right? So I've done it. So technically, they'll give you a rules of engagement document, which will have what scope you'll have, what user you're gonna get provided with the company to audit or pen test. We're gonna get a lot of network testing, pen testing a lot in cloud accounts as well. So for that purpose, they'll give you a specific access. From there, you're gonna do policy enumerations like exactly what we did. And again, the end of the session, I'm gonna give you real quick tips like maybe hacks, which you don't have to do everything manually like this. Whatever we're gonna do, because there are a lot of automation tools, a lot of stuff that can automate these things, but there are trade-offs. when you're going to use these automated tools, frameworks that are developed by Rhino Security Labs or anyone, the only small issue is they'll create a lot of noise. Your defender, or I mean, if you are doing something in a black box testing, something like that, or red teaming engagement, easily your defense teams or your defending teams can identify that they're doing a lot of API calls, a lot of noises going on in a specific region, right? But this is something manually, if you're doing it, I mean, it takes time, but again, it'll be a little bit stealthy. It's not 100% stealthy, but yeah. So, yeah.
Right. So, real quick exercise. In this one, in this scenario, we got our credentials from GitHub. Can you think of any other ways we can get AWS credentials to start with?
Yeah, one thing is, as I said, like GitHub would be your main source to find or hunt the AWS credentials. Can you tell me what are other sources of finding the credentials?
Yes, go ahead.
We need like a DevOps CI/CD pipeline.
Yeah.
I know there's what I'm familiar with is
Yeah.
an API user
Uh-huh.
within the pipeline assuming roles
Yeah.
or like from GitHub,
Right.
and then it interacts and then it assumes the resource
Yeah,
permissions
yeah,
to
Yep.
AWS.
Yeah.
And so to me it's very advanced. I'm not even
Gotcha.
near that, but like
Yeah.
an idea is like pen testing when it starts to assume those roles. And
Yeah.
you can like sit in the middle of that.
Right.
You-
Again, that's from GitHub, right?
Yes.
I
So
mean, if-
that is one way you can do it if you have access to that DevOps pipeline, obviously. Yeah. But it's simpler than that. For instance, I've seen credentials in website source codes. So JS files just have, for instance, it's a website where I'm uploading something and they move those files to an S3 bucket, which is what AWS uses to store in data. I've seen the credentials for those for that S3 bucket on the source code. Yes, someone else had their hand.
Have you ever seen credentials stored in like Datadog or something?
I personally haven't, but yes, you could have anything. It depends on how it's developed. Obviously, if those logs are being sent to Datadog, then yeah. Do you have something to say about that?
No, I never used Datadog.
Gotcha. Yeah, but yeah, yeah. So these are some ways. In a regular pen test, if you have access to someone's system, AWS credentials are stored in a file on the system. So that's another way you can get it. Another way is one of the scenarios here that's under this one. So this is a very common AWS and cloud provider situation, where if you have a website that's hosted on an AWS server, there's an internal metadata server at 169.254.169.254. I see a lot of nods, so you've heard about that. You can reach out to that service using an SSRF vulnerability, and you can get credentials from there. So a bunch of different ways you can get credentials. Yeah.
And any one of you are from AppSec background, application security, or Android pen testing? Okay. So just wanted to provide a couple of resources. If you are from AppSec, a lot of people might find these AWS credentials in JS files, what Deepak said. And there are a bunch of tools to collect all the JS files from your web application. Because I worked as a bug bounty hunter and a pen tester with Info. So I know that how to find these JS files, and then in those JS files, a lot of times it will be pretty straightforward that you'll be able to find credentials. But in the worst case, there will be attackers. We are the attackers, right? For us, the worst case is they might get obfuscated. So we have to deobfuscate them to see the credentials. And one other use case is if you have ever performed Android application testing, something like that. So when you decompile the APK file, I'm sure that you might all know what's APK file if you have the Android mobile with you. The APK file, the moment you decompile it, you have a strings.xml file which will have all the strings that's going to be used inside the application. A lot of times, I mean, we can find the credentials from there as well. So it's not just one or two or three places. There are a bunch of places where you can find these credentials. And then, yeah, this is really important to know because that's our initial access, right? That's where you get the initial access to your any target cloud account. And the most important part in any red teaming management as well. So, look the compute.
You can do like Cognito. You can walk through. I just want to do compute. No time for compute. Yeah. So then we'll do Cloud Nuke then, and then we'll start. No, let's forget compute.
Okay. Those the second service.
So yeah. So the example that we showed you before, which was the EC2 SSRF instance. So Cloud Code provides a scenario for that as well, which you can spin up and test it out yourself. The Cloud Code scenario starts similar to how the previous one did, where you're given access to a user, and then you move laterally through the AWS network until you discover an EC2 server. So like I said, so initially you have access to a user along with their credentials, and you're just going to configure it. So I'm going to skip through some of the configuration steps, which he's already covered. Sanity check, just to make sure it works. It does. Now we have a username, and we're going to start by enumerating Lambda functions this time. So does anyone know what Lambda functions are? Show of hands. Yeah, okay, some of you know it. Yeah, so some of you know what Lambda functions are, some of you don't. It's Amazon's version of serverless. So you give it a Python file and it'll run it. You don't need to provision specific EC2 servers. It'll handle all of that by itself. Why are we doing that instead of policies like we did the previous time? That comes down to the previous question that was asked, where we kind of know what exactly we want to enumerate because we're setting up the lab. But if you didn't know about that, you'd have to go through all of the services. You'd manually go through all of them, or you'd probably use an automation enumeration tool to see what permissions you have. But in this case, we're doing Lambda because that's what we have access to. And we're going to list the Lambda function that this user has access to. And what do you know? You have environment variables right there with access keys. So this is probably an instance of where the Lambda function needs to access another AWS service. So they've configured AWS keys in there. And this user has access to Lambda service. So now we get another pair of keys. We use those keys.
So how many of you know difference between EC2 and Lambda? Okay, so your EC2 is a compute server, like just like how your CPU works, and your Lambda is a serverless function. So Lambda works on if you run any Python, simple Python scripts, right? Each and every function will have, they don't have any backend server. It just runs serverless. That's your Lambda, right? Yeah.
That's why it has all the information stored here, because every time it runs that file, every time someone's requests a service, it has to run that script again, and it needs like environment variables and everything. But yeah,
Lambda has those Python functions or the code, right? So a lot of times that code will have these credentials. As I said, these credentials are again used to call some internal services for some reason. So this is one of the most popular example that a lot of times you will find these credentials in Lambda functions as well.
so now that we have a new set of credentials, we repeat the process where we configure our AWS CLI to use those credentials. And this time, once again, we kind of know that we want to target EC2 because of the way the scenario is built. But if we didn't know about that, we'd enumerate everything until we find that this set of credentials has access to EC2. So this time around, we're going to describe EC2, which just means it's going to give you a list of the EC2 instances that are running, and it's information about that EC2 service pretty much. So you have what you'd see in a regular computer. You have a device, disk volume. You have information about metadata about the AWS service itself. But if you scroll down, you'll see that, which is its public IP address. It also has a public DNS, which is linked to Amazon AWS. For this lab, we're just going to use the IP address.
Why do you think that
Yep.
Why do you think that we have instance profile attached to it? I mean, why? Right? So the reason is whenever you attach an instance profile to an EC2 server, right? So that EC2 gonna use these credentials to perform tasks on behalf of a user. right? So that is sole reason you will have an instance profile that got attached. Now our main goal is to compromise that instance profile by SSRF.
SSRF. Yeah. So show of hands who knows what an SSRF is. Yeah. Okay. A couple of you know what an SSRF is. So here we have a website which just says, "Welcome to SetSex demo SSRF." I'm an application. I want to be useful, so give me a URL to request for you. And if you know any, if you're a web pen tester or you do bug bounties or something like that, this kind of gives you a hint as to what you should do, which is to give the URL, add a URL parameter here, and then you can specify what you want it to request. So if you do URL equals google.com, it'll send a request to google.com and it'll give you the response for that. So that is what's called an SSRF. It's a server-side request forgery attack. So it's called an SSRF because the server is the one sending the request to Google, or in this case, that IP address, not you. So the server kind of acts as a middleman. You tell the server, hey, I want to talk to this website, and the server goes and does it. And it's useful to us because Google.com, well, we have access to Google.com, so that's not a big deal. But this server could be in a private network with access to other services, which are not publicly available to the internet. But using an SSRF, we can request this server to send a request to those internal. Yes, go ahead.
Like you're tricking the server to call an external network. So basically, SSRF is one of the worst of the vulnerabilities. So basically, you trick the server to call to an external resource. And in our case, the external resource is something, but we can call external server. But our whole goal is to, as I said, we're going to compromise the instance role, right? We're going to call some internal IP.
Yeah, sorry, I saw a hand raise over.
I was just curious, I thought this was all blocked by
Yes.
So technically, okay, before 2019 or 20, sorry for that, I don't remember the exact year, but AWS used to have IMDS V1. What's IMDS V1? IMDS V1 is instance metadata version 1, which imagine the same scenario, like if the website had an SSRF vulnerability, right? So typically, if you exploit that SSRF vulnerability, you'll be easily try to compromise that instance role that I mentioned, right? But later, AWS came up with a new solution. That's the IMDS V2. You'll not be able to directly compromise via SSRF, but still you can do via HTTP put request. So I want all of you to quickly check what exactly an IMDS or IMDS V2 is. Like open up your browsers and see what is IMDS. So, and what is IMDS V2? So you can still compromise IMDS V2 just by doing HTTP put request in the command line, and still you'll be able to fetch the instance metadata credentials, right?
So, well, thank you for that question.
Yeah.
Right. So in this specific case, we know that EC2 uses a specific IP address for their metadata server, which is the 169.254 IP address that you see over there. And there is a path that you can, this path over here. This gives you the access to whatever security credentials that previous profile that we saw that was attached to the EC2 instance was. So if you can send an SSRF request to that service, it'll just give you the role over here. So this is the role, CG EC2 role. And then once again, you just request for that specific role, and it'll give you the access keys over here, access key and the secret access key right next to it. So this is another way you can get credentials. And then once you get that, you repeat the same steps. You go through this whole process again. You configure the new keys and you enumerate and you keep moving through the network. In this case, I'm just going to skip ahead. But in this case, we have an attacker that can, yes. Yeah.
Can you see that access key ID marked in a red box? So this is the difference between compromising a user and a role. What we have compromised is a role. How do you identify if you have to compromise a role? Like you have an access key ID and secret key. Can you see that session token? Yeah, can you see that token double quotes?
It's
in a submittal. Yeah.
this one.
So your token is something, it will have a temporary access. So it's basically a node.
Yeah. Yeah. So you repeat the same steps again. You have new credentials, you use that. This time we're enumerating S3 buckets, as you can see, where you find a new set of credentials. Does anyone know what an S3 bucket is? Yeah, you guys know what an S3 bucket is? Okay. So yeah, you get a new set of credentials, you configure those credentials, and then we come back to Lambda where we list new Lambda functions. And finally, we have a function that we can call and we invoke. And when we call that function, it says you win. Really, at any point throughout this thing, throughout these steps, you keep gaining access to new users. Each of that is its own vulnerability in this case. So the scenario specifically ends here, but in an actual scenario, a single user or a single role will have access to probably multiple different services. So you'd have to like branch out and keep looking through all of that. So real quick, it's a slightly longer exploitation path, but yeah, it's pretty much what we just showed you. So any questions with this, or we'll move on to a tool called Cloud Nuke. Yeah. So Cloud Nuke, shout out to the folks over at.
So since this is a deliberately vulnerable lab, you will see a lot of steps, a lot of things to do and commands and stuff. But in the real world case, trust me, I've done a lot of stuff. I've written blogs. One command and then you'll land into administrative access, or very, very few steps that you'll land having more privileges of the users, right? And yeah, you can go to Cloud Nuke. And the rest of the documentation, you can do after going on. We have some time constraint. So we have documented each and every command, every output with the screenshots as well. We'll leave in the end 5 minutes to ask questions. Yeah, so we would need to go with the cloud.
So
if you're doing it,
yeah, so Cloud Nuke, it's quite simple. So for the previous scenarios that we showed you, Cloud Goat offers a way to delete those resources. So it uses Terraform to provision resources, and you can use Terraform to delete resources. If you don't know what Terraform is, that's completely fine. You don't need to do that. But what Cloud Nuke does is once you configure your AWS keys, what Cloud Nuke does is it goes through all of your AWS resources. So this is an example of me running Cloud Nuke. I'm setting it to that profile because I want Cloud Nuke to use that profile's keys. And I'm using AWS because AWS is the cloud provider in this case. And region is US East 1. And that's just, I just limited it to East 1 because 1, I provisioned all my resources in East 1. And 2, if you don't provide that, it'll scan all regions, which will take a lot more time. But you can see that when I run the thing, when I run the command, it's going through 119 different resource types, and it found a bunch of different resources. Anything in blue or bluish green that you see here are resources that Cloud Nuke identified. And then, yeah, go ahead.
Is this really similar to CloudFormation?
So CloudFormation, I believe, is used to provision resources with like Terraform. So that's more similar to Terraform, what I just mentioned before. Yeah, go ahead.
yeah, this
So Cloud Nuke is not using Terraform at all. It's using your AWS keys, and then it manually goes and scans all of your resources. So what you see here, it's kind of like your what your second question was. It identifies all the resources, which is how I kept mapping out what all I provisioned and stuff. So once it does this, it actually prompts you to enter something in before it starts deleting resources. So if you just want to check what all resources that you have, you can just do that as well. There are other tools to do that, but yeah, you can use this to do it.
The question was, what's the difference between, or is it like similar to CloudFormation with Terraform? The CloudFormation is something that's specific to AWS, whereas Terraform is something like infrastructure as code you can use across different cloud providers. The second one, Cloud Nuke, is something that, as Deepak said, but just a heads up that it will also delete by default resources that AWS gives you.
Yes. So if you see this right here, the Internet Gateway resource, and there's VPC, which is the default VPC that AWS created. So during my test runs, I ran this and it deleted all of these resources. And then I provisioned something again, and I couldn't connect to it because it had no Internet Gateway. It couldn't reach out to the internet. So yeah, if you use Terraform, you can use Terraform to destroy it. That keeps track of everything. If you don't, if you lost track of your resources, which if you work in this field, you will probably do that, and you want to delete stuff, you can use this. You should check out the tool a little more because they have different arguments that you can use to specify what you want to delete. You can delete specific resources if you just want to delete EC2, or if you don't want to delete EC2. But yeah, that's about this tool. Just real quick, it just shows you what we have. And then it starts deleting everything. So just deletes all of this. So we're nearing the end of the demo. If you have any questions, we'll go ahead. So in this case, I'm actually not sure, but we use an admin account for the creative. I will actually have to get back to you on that. Yeah. Gotcha. Oh, I think it's, I don't know. I'm not sure if the AWS access keys require but yeah. Sorry, yeah. What was that question over there?
They want to get to the
The URL? Yes. Okay. So just give me a second. All right. Thank you.
Folks, hope you enjoyed. Just let us know if you have any questions. The documentation at the end, you'll find our contacts as well.
Yeah.
Thank you so very much, Bhagwan and Deepak.
Thank you.
Guys, these are fresh graduates, so please give them a big round of applause.
Thank you so much. Thank you. So this is the URL. If anyone wants, if I also have it here, I can give you a QR code if you come up to me, and that's easier for you.
Thank you guys so much.
Thank you. Hope you guys learned something.